Once again, Assalamu alaikum. In our last lecture, we started with the inheritance, and we just covered the basic things that what is inheritance and why do we need it. Let's revise it before going to advanced level of inheritance. Let's discuss the basic that why do we need inheritance and what is the problem actually, which lead us towards the inheritance. This is the basic program which we are looking in our that tutorial, and we for the university system we considered all these object as a classes, because the teacher has some responsibility in the university application, the student has some responsibility, similarly the admin has some responsibility in the university program. And when we go for the designing of these classes, then we need such type of data, we need such type of data type, data members, as you can see over here. For the teacher we need some data type, for the student, and similarly we also need some data type, some data members for the admin too. But what issue actually arises that some of the data members which you can see over here, that they are repeatedly used. The name, address and phone number is same for the teacher, they are also same for the students, and you can say that these data is also same for the admin too. But according to object oriented programming, which were the basic rules and regulations, and we discussed that slide earlier in our first class, then we discussed that the main purpose of the object-oriented programming is the modularity, that we are putting the program in different modules instead of writing everything at one place. Similarly, the second thing which modularity lead is reusability. It means that we are not going to repeat the code, we will reuse it. This is the main problem which we have. Here you can see that we are violating the rules of object-oriented programming, where we explicitly talk about that we will not repeat the code, we will reuse the code. And here you can see that instead of reusing the code, we are repeating that code. So how can we design a structure to avoid the code repetition? For that we go towards inheritance, and here you can see that this is a person class. We have uh, design one person class, and in that person class you can see that we have some data members, name, address and phone number. You can say that these are the same data members which were being repeated for the students, teachers and admin, and for that we have created one third class. This is a person. So all these are the data members which are common for the teacher, these are also common for the student, these are also common for the admin. So what we do after defining the person class, we derive other classes from that. As you can see over here that I'm deriving a teacher class. The teacher, which is a child of the person, also inherit all these three data members, and we also include these two data members. So teachers totally have 5 data members. In the student you can see that we are also inheriting all these three data members, and along that we also add these 2 data members, and we can observe the same behavior over the for the admin too. Now it is perfectly following the object-oriented programming rules that our program is in module, and we are not repeating the code, we are reusing the code. And here you can see that we are not repeating the code as we did earlier in our initial design. Here we are reusing the code. So this is the main purpose of inheritance, that we go towards inheritance, that we want to reuse the code instead of repeat the code. Now today we will further discuss the single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and then we will go toward the hybrid inheritance. But before that we need another thing that is called a constructor. This is actually constructor, not a destructor. So how constructors work in inheritance, that is a problem, because what we do, we inherit one class from the other class. So the parent class also has a constructor, and similarly the child class also has a constructor. This constructor is public. It means that this constructor is also inherited to teacher 2. Now the teacher, which is actually a child class of the person, has two constructor. One is its person, which is inherited from the person, and the second is the teacher, which is its own constructor. So the issue is which constructor will run first. If you write like that, then which constructor will run first? This is the issue. We need a solution for that. And sorry, if you observe the things over here, then as a nature phenomena works, then according to the nature phenomena, so what do you think that which constructor should run first? Either the system should run the teacher, the child class constructor first, or either it should run the person class constructor first. So what we can do, we should go to the program and we should write a program over here. To instead of writing a new program, I think we should use the earlier written program to make the thing easy and to go ahead. And I should save it with inheritance with constructor. So this is the program with inheritance with constructor, and this is the same program which as you can see. So what I'm going to do, we are not dealing to all these data members currently. Similarly here, I'm not going to deal with all these data members, and here too I'm not going to deal any data members here. So this is a parent class, as you can see over here. This is a child class which is written over here, and this is its this is its object which we are which we are creating in the main. So our problem is that the person, which is actually a parent class, the parent class has a constructor. So we are going to write one constructor over here, and in that constructor we want to display some message. This is a parent constructor. Okay, so this will print a message for the parent constructor, and similarly in the child we will also have one constructor also. We are keeping the constructor public because we always keep them public. The class name is a teacher, so the constructor should be a teacher, and in that I'm also printing one message, and the message is this is a child constructor. Okay, so we have two classes. The one is a parent class, and in the parent class we have a constructor. We have the second one, teacher class, and teacher class as you can see that it is inherited from the person, and it also has one constructor. Now what we are going to do in the main, as you can see that we have created one object of t1, and according to the constructor definition, as the object is called, the constructor should be automatically called. But the issue is the teacher has also inherited the person constructor over here. So which will run first? Let's check the behavior. Message is being displayed, teacher T1. What is going on? So the system was actually running the previous program, so let's run it and check its behavior, how it works. So now you can see that it is running the parent constructor first, and after that this is running the child constructor. So why it is behaving like that? Before that, we have discussed a number of things, particularly related to the object-oriented programming. As we discussed, that object-oriented programming actually behave as nature behave, that this is a parent class and this is a child class. So the constructor of the parent class is trying to set the data for its data members of the person, and similarly the teacher constructor is also trying to set the data for the teachers too. So the teacher will actually set the data for few data members, the different few data members which we assign to that. For example, the constructor will try to set the employee ID and specialty. So if we run the child constructor first, then these values may be set it accurately, but there can be a problem with the parent class and with the parent data members. So avoid this issue, what we do, that first we execute the person class, the parent class. So all the data members are initialized for the person, and after that we execute the child constructor to initialize all the remaining data members. So this is the basic reason that we first run the parent class constructor, and after that we go towards the child class constructor. So the next thing is destructor, and here you can see that in the same way we have one a person class in the person which is actually a parent class, we have a destructor, and the same way we has a teacher which is actually derived from the person, and the teacher also has a constructor with teacher. So still there is a confusion that when this object will go out of the scope, which destructor will run first, either the person destructor will run first or the teacher destructor will run first. So keeping in mind the definition or the purpose of the destructor is that actually we want to destroy the object, we want to release the memory, we want to release the resources which were being allotted to all the objects which were in service, which were in the life cycle. So in the constructor you allot the resources to the object, and in the destructor you actually get these resources back from any object. So as a programmer, as a student, you should think that which one should die first, not as a natural life but as a programmer, as any you can say as an application. For example, there is an application, we click on the other links and the other windows are open. So which window should close first? This is you should think about that which window should be closed first. Meanwhile, we check its behavior, that how destructors will work in the object in the inheritance, and the destructor syntax is the same as we write the constructor where that we will use the same name, we will use the same name function as a class name. As you can see here that the class name is a person, and we are using the same name for the destructor too, and we will use the same function as we do in the constructor. So name, same name, no return type. The only difference is we will use a tilde sign over here. Okay, so in that I'm going to display one message, and the message is this is a parent class destructor, handle. Okay, and the same way we will also have one destructor for the teacher too, because teacher is a derived class, and it is completely playing its role as an individual class. The rule is same. We will need a same name as we have for the class. The only difference of the destructor with the constructor is that I will use a tilde sign over here, and similarly I display one message over here that this is a child class destructor. So let's check its behavior. Now earlier we checked the behavior of the constructor, that in the constructor the parent class constructor run first, and after that the child class constructor runs. So let's check the behavior of the destructor, that how it behaves and how it works. So in the case of constructor, sorry, in the case of destructor, you can see that this is a child class destructor and this is a parent class destructor. So this works in reverse, that the parent class, the child class constructor is run first, and after that the parent class destructor is run. But in the case of constructor, first the parent class constructor is run, then the child class constructor is run. So it is completely reverse for the destructor. The destructor is run for the parents. So let me take you back over here, that in the case of destructor, for example, you have opened one application, and that application, after clicking the links and other resources, you opened and different tabs. So if you close that tab, there are chances that the resources occupied by all these tabs, all these applications, may not be deleted properly. They may, you can say, remain to open, and the basic purpose of the destructor is that we want to free the resources may not be accomplished. So this is the reason that before distracting the parent, we remove all the objects. Okay, after removing all the objects, after running all the destructor, then we run destruct the parent. So this is the main reason that why do we read the destructor first in the inheritance. Now hopefully you understand that in the constructor, the parent constructor is run first, then after that the child constructor is run. The basic reason is that we want to initialize all the data members of the parent first. After that we want to initialize the children derived classes data members. And in the case of destructor, you observe that the child class destructor is run first, and after that the parent class destructor is run. And the main reason behind that is, if you have open number of classes, number of objects for any class, then if you close the parent class, then there are chances that the resources occupied by the child classes, by the child object, may not be deleted properly, and they may continue of resource utilization, which is our basic purpose. That the destructor basic purpose is that we want to free the resources from these objects. So in case if you run the destructor of the parent first, we may not meet the requirement of the destructor to free the resources from all the objects. So hopefully you can understand it, what we discussed. Now we should go a bit further, that is access modifiers in the inheritance. We have already discussed the access modifiers, we have already discussed the encapsulation and its working. Let's repeat it and we will cover the missing one. Public means that the public data members are available everywhere. Protected means that the data will be available in the child classes also. So when we were discussing the access modifier encapsulation in our first class, at that time we explicitly discussed the public, we explicitly discussed the private access modifiers, but we just thoroughly discussed, or we just only theoretically discussed what protected means, because at that time we were not able to discuss the inheritance because we were unaware that what is inheritance and how inheritance work. So because now we have studied the inheritance, we know what is the main purpose of inheritance and how it works, so we can see it also how the protected behavior works in the inheritance. Rules are the same. Public will be available everywhere and private will only be available in its own class. And protected, you can say it is just like a relationship, that the protected data members will be available for the parent class in which they are written, and similarly they will also be available for the children classes. So let's go and we extend our program bit further and check that how can we code it. I copied the same code and I copy it again over here. At that time I need some data members over here. For example, I need some private data member because we want to check its behavior. So some private data members, and in private data member, for example, our phone number is a private data member. Similarly, we also need a protected data member because this is the first time we are checking the behavior of the protected, and in that I'm declaring address. And in the public I need another data member. For example, this is the name and this is the protected data member. Let's go to the main, and in the main let's check the behavior. For example, t1 dot t1 is an object of the teacher, and there we in the person we define number of data types. We define name, address and phone number. So for example, if we check that with the name and I try to provide some data to that, and you should keep in mind that name is a public data member, so it will work because this is a public inheritance. Access modifiers, so it will work because we are trying to set the public data members, and public data members are available everywhere, and you can see that it's also working. It is not flagging any error. So the next thing is I'm setting t1. T1 is an object for the teacher, and we have address over here, so I try to add the address also. So now you can see that I'm trying to add the address. I think this will this may create some confusion that it is not providing an error. What I should do, I should write some data members. You can say I should write any function here to show it completely. For example, I write a void show, and this is a person show, and in that I will display some message. For example, the message is see out. This is person, which is actually a parent class. This is a person protected. Okay, this is a person protected, and here I should write it as a person protected. So this will bit clarify that what we actually want. Currently I don't need constructor and destructor, so I remove all that. Exactly in the same way, I don't need any constructor or destructor over here. We just want to practice it how it works. So what I want to do in t1 dot, and I want to access the protected data member. I want to access the protected function, which is a person protected. So let's try, can we access it over here? So this is the person protected. Where is the person? And I think this was a protected, and we try to access it. So it will not work because we have already discussed that the protected data members are not available in the third class, and main program is always considered as a third class. You can see over here the message that person protected is protected, so we are not able to access it in the third class. So let's do another thing. We copy the same program over here in the public. Now this is a person public function. This is a person public function. Let me rename it. So this is a public. I should change it to public here too, and now I will call the same person public. And now you can see, because this was not working, I should also comment it over here that protected is not accessible, or you should say available in the third class. The main is always considered as a third class. So this is our learning. And then the second thing is, now I'm going to try T1 and person, because I'm going to person want to access the person function, and at that time I'm going to access the public one. Okay, so this should work now, because we know that the public is available everywhere, and hopefully this will work. This is a person public, so you can see that public is available in the third class. Now what we should practice it a bit further, that this is a child class, and in the child class we do such like practices. In the child class I need one function over here, for example void, and this is a person private. I will try to get the same function from the child class, and we'll see that either it is accessible or not. Person private. Okay, this is a one person private class, and we will try it through accesses from the child class. You should keep in mind that currently I'm accessing that from the teacher, from the derived class. I'm not going to access it from the third class. I'm going to access it from the child class. So I'm going to set these values first. We can also call that directly from the second class, but for that we will need to create the object. So instead of that, we are going to set the value of phone. Let's check whether it is available or not. So I'm going to write one function over here, set private, and in that private I try to set the value of phone. Phone is a private, so I want to assign phone number here. So what I'm doing, I'm in the child class teacher, I want to access the phone number which is actually a private. So this will not work because private is not available in the child classes. So we can exactly see over here that the parent class private is not accessible. Let's do another thing, and in the second case let's check that either protected is available or not. Okay, and the protected one is address, and I call here protected because I'm calling a protected one here. I'm setting a protected one here, and the value is address, and keep the value the same as the address. Okay, let's check whether it works or not. It is not flagging an error. It means that it is working, but if you want to check it, then you can also call that this function over here in the main to call it. one set protected. So the set protected is actually a public function. This function is public, but because this is in the teacher class which is derived from the person, so this is the reason it is able to set the value for that too. This is the reason it is able to set the value. So hopefully you can now recognize how actually access modifiers works in the inheritance. We should look at that here too from the slides. After the code, I think you can easily understand it over here. In the public, as we observed that it is available in the parent classes, it is also available in the children classes. These data members are also available from the third classes, as we observed that all the data members were available in the main classes. In the case of private, we observe that all these data members are available only in the class in which they are written. They are not available in the child classes, and they are also not available in the third classes. Similarly, in the case of protected, this case is a bit different. They are available in the parent classes as the private and public, but they are not available in the third classes. So this behavior is matching with the private one, this behavior is matching with the public one. But here they are available in the child classes too. We can access these data members from the child classes. This is the difference, which this is the you can say attribute which make the protected different from the private and the public one. So it is actually sharing its resources with the children, that the child can also inherit the protected data members. If any property, if any function which are protected, which access specified is protected, then all these data members and all these functions are also inherited by the children too. So hopefully I think now you can understand that how the access modifier works in inheritance, and we should go further towards the types of inheritance. We have already practiced the single inheritance, and now we should go to multi-level inheritance. This is a multi-level inheritance. Multi-level inheritance means that we have a data members over here, and we want to inherit the B from that. Then all the public and all the protected will become a part of B. Now because B is another individual class, so all the data members which were inherited from the B, which were inherited from A into B, all these are parts of B now. And when any the third class C is inherited from the B, then the P should also will work over here. So the inheritance flows in the level as we go further. This is the level number 1, this is the level number 2, and this is the level number 3. So let's check the same, that can we have the same inheritance in the next level or not. I think we should write a new program for that, because this can confuse the earlier program if we write everything over here. And I should also change the class's name. I should keep the class's name on the level. This will clarify their understanding. Okay, instead of writing the class person, I'm writing a level 1. This is only for the understanding, and this is level 2 because in that class we are at level 3, and I need another class level 3, and that level 3 will be inherited from the level 2, and the level 2 is inherited from the level 1. Okay, so now you can see it exactly look like that. We have one class with level 1, and from that level 1 we inherited class level 2 from level 1, and from that level 2 we have inherited level 3. So let's continue further, because we have to observe the inheritance in different levels, that either it can carries the data members and functions of the level first into level 2 or 3. For that reason, I will uh, need different data members with different access modifier, and I think we shouldn't go with the private one, because private is only accessible in the uh, base class, and after that they are not available. So I will only go with the protected and the public one. So protected, in the protected I have string, for example address, and in the case of public, for example, I have string name. So these are the data members which we have defined at level number 1. To check that either we are getting it or not at level 2, I think we have already practiced here that all of these data members were available in the children classes. So instead of focusing on that, we should go to the level number 3. This is the level number 3 which we have inherited from the level number 2, and here we should check that either we are getting that values or not. So public, and in that public I want to write one function, for example void, and the functions is to set the values, and in that function we are trying to set the values of level 1 data members, and these are the addresses and name. So first try to set the value for name, and name I'm providing some name to that, and along with name I also set the value for the address too, for example abc001. So this is the function which we used in level 3 to set the data members of level number 1. So let's go back into the main, and with teacher 1, this shouldn't be teacher now, because we changed that to level 3. Level 3, and L is not in capital, level 3, and for that I'm going to create one object L3. So with L3 I will call void set values, because I'm trying to set the values for that. Okay, uh, I think we should also print that values to make the things more clear. So I need one other function show, and in that show I will print the value, for example the name, I'm also printing the second data members, which is address. Its data member name is add and handle. Okay, so along with setting the values, I will also print the getting the values or show the values, and I think we use the L3 dot show. Okay, this was the show function. So let's execute it. Multi-level inheritance. So you can see that we are able to access the both values, the protected one and the public one. Here you can see that all the data members which are protected and public, they were accessible in the B, and the same behavior follows up, and we were also able to set that values from the C. So this is perfectly working. Now we should go toward the hierarchical inheritance, and in the hierarchical inheritance we have to check that can we inherit more than one classes. So in that case, for example, the level 2 is inherited from the level 1. Now the level 3 should also be inherited from the level 1. So now this is the case like that, that from the A we are inheriting B and we are inheriting C. This is the same case, and you can see over here. This is level 1 class, and in that level 1 we have some data members which are protected and public. I'm not using the private one here because we already know that private are not accessible. And this is the other class which is also inherited from the level number 1, and this is another class which is also inherited from the level number 1. If you are getting confused, I should replace it with A, and that should be now B. B is also being derived from the A, and in that case that should be C, and C is also being derived from the A. So both of the B and E is being derived from A. And in the B class we should also print that, because the B is an individual class. Now in the main, let's check that either it's working or not. Currently we have two classes. One is a B, which is derived from the A, and we have B1 for example. B1 for example, and similarly I have one C, and I'm creating its one object with C. So we have three classes actually. The one is parent class, and this one is a parent class which is declared with A. Then there is a B which is derived from A, and there is also a C which is derived from A. This is exactly the behavior which we discussed over here. Okay, so now we will call the B function with the object and the C function with the object, and we'll see that either it is working or not. Let's go towards the main, and in the main with B1 object I will call the set values function. I will also call the show function to show that either it is working or not. So for B, let's see either it is working or not. So for the B, you can see it is correctly working. Exactly for the C, I will call the set values, because I need to set the value for the C1 also, and I will also call the show to get the exactly same values. Now you can see that this is working for the both classes. It is also working for the B, and it is also working for the C. This is the inheritance, hierarchical inheritance, which we usually use the most in our programming. That we write the program, we write the class once, and after that we write different classes from that according to our requirement. So now up to that we already know that what is a single inheritance. Then we also discussed the multiple inheritance, then we also discuss the multi-level inheritance, and then hierarchical inheritance. Now we should go toward that phenomenon. I think we are missing one thing. Initially in the first day we discussed the single inheritance, and yes, we are missing the multiple inheritance. Multiple inheritance means that we have two classes A and B, and they have different data members, and in the C we need the data members from A. We also need some of the data members from the B. So all the data members from A and all the data members from B will come into the C class. So let's check how can we code and either it is working or not. So in that case, for example, I have one class A. I'm keeping everything public over here because we are just practicing and checking how is it working. And similarly in the B class I have some data members, and the data member is, for example, in the A I have the name, then here I should have the address. Okay, so we are just having two data members, and the B is a different class. It is not a child class of A. A is a different class, parent class. B is a different uh, parent class. The C should be a child class, and we are going to derive it. So what we can do here, we are going to derive C from A also, and also we want to derive it from the B. We are getting both the values, both the data members from A side and also from the B side. So the inheritance way is, the syntax is, we just separated the classes with comma, then public A and then public B. So we are publicly deriving the C from A and also publicly deriving the C from B also. So what do it means? That currently in that case we will have all the data members of A and B over here, which is actually name and address, and this should allow us to set that value, and it should also provide us access to show or get that values. So in the same case, because currently I'm dealing with C, I have derived the C from both A and B, as you can see over here. So I have created one C object C1, and along with that I'm using that to set the value for C. You should keep in mind that all the data members which we are going to set over here, all that belongs to the parent classes A and B. C don't have its own data members over here. So let's go and check its behavior. So now you can see that we can successfully access the both classes data members. We set the data members for A also, and we also access them, we also print them. We also access the data members of B, and we also print them. Now we should go towards another type of inheritance, which is called a hybrid inheritance. And in that inheritance we will practice the both. We will have one class A, and from that A class we will derive two classes B and C, as we just practice over here. And from that B and C we will have a third class D as a multiple inheritance. So let's check how it will work, but you should keep in mind that there may be an issue if we have any function over here, that can be any type of function or any type of data. The same will be a part of B, the same will be a part of C, because both of them are being inherited in A. So the D will be confused, because they will have the same data members and the same data function at B and also at the C. So how can we address that problem? Which function or which data member the D should get, either from the B side or either from the C side? That is called a diamond problem. We will look at that problem, and we will also see that how we can address that. Let me write the program first. This is for example A, and in that I'm adding simple function over here to show that this is class A, class A, and I'm just printing that this is class A. This is class A. This is a single simple message. Okay, now I need to derive B and C from that. In the B I will derive the B from the class A, and currently we don't need to add some data over here. And similarly I will need another class over here, for example, that is class C, and it is also derived from A as we discussed earlier. Okay, so now you can see that here we have two classes and both of them are derived from classes A, as we observed over here that we will have the same classes, hierarchical inheritance, which is derived from the A. So up to that we have coded that class B and class C both are derived from class A, and in the class A we have some simple data members and one function. So our third task is that we are not going to write anything over here. So in the class C, you can see that we are inheriting class C from the class A and class B. So what do it means? It means that this function, which is a class A, is inherited from A to B and C also. And when we inherit the C from multiple classes from A and B, then C will get confused that either it should get the copy from the B or either should get the copy from the C. This is actually a C, not a D, and D is inherited from B and C. Okay, so this is the same problem which we discussed earlier. So here I will just create a D object, D1, and let's check its behavior. And I think the function name was class A. Yes, the function name was class A. So look at the code once again. We have a class A, and in that class we have class A function. We defined that function over here to check its behavior, because the class B and class C both are derived from A, so both of these classes have that function. And in the same way we further have a multiple inheritance in which D is derived from B and C. Now here is the confusion that D is deriving that class A from B also. It is also having the same copied B, it is also having the same copied C. So D may get confused, D may find it ambiguous that how can the same data members and same data function can be replicated to two different classes, because according to the object-oriented programming we have a strict restriction that we will not repeat the code, we will reuse the code. So if this is the rule regulation of the object-oriented programming, then why D is getting the same function copy or same data members copy from that both classes? So according to the rules regulation, this is the issue, and the compiler should reflect on that. And you saw that as I compile it, it is not being compiled and it is flagging an error that class A is ambiguous. Definitely it is ambiguous, because this function, one copy is created for B, the one copy is created for C, and when then D is derived, the D is getting the same function copy from B side and from the C side. So this is exactly ambiguous. So what we can do for that, to address that issue, to address the diamond problem, because this is a diamond problem, the class D is getting the same data members of the same function. For that we will make the class B and class C virtual. when these classes are made virtual, we haven't yet studied the virtual completely, how the virtual works, how the virtual keyword actually works. Virtual means, though we will cover it in further polymorphism, what do the virtual keyword will work over here? It will create the copy for B and C. Instead of providing a copy to B and C, it will create a virtual single copy. It will only forward the single copy of A instead of providing a separate copy to the B and C. And the D will consider the B and C as virtual, and it will get the direct copy of A. So in that case, only the one copy will be forwarded to the next hierarchical level, and the D will get the exact copy, the one copy which was forwarded from the A. So there will be no confusion over here. So I'm using a keyword virtual here. So I'm inheriting B as a virtual class, I'm inheriting C as a virtual class. Now, because the B and C are virtually inherited, all the data members which we are having over here are in virtual, so we can now access the copy of that data members. We will discuss in that what actually work, what is the polymorphism later on in a polymorphism, but currently you can see how it works actually in the programming. It is taking too much time in running. So now you can see that it is correctly run and there is no issue in that. So you can see that we cover the inheritance. We cover the inheritance in very detail. Let's revise, recap the program, what actually inheritance means, and what did we cover in our program, and why do we need inheritance. So why do we need inheritance? For example, we were working on a program to develop any program for the university, and for that university program, we decided these objects. And when we decided these objects, then what we do, we decide that these are the data that should be these are the data members on which we agreed. But after agreeing on that, we can see that some of the data members are repeating. But according to the object-oriented programming, we are not going towards the repeated data. Instead, we go with modularity. Instead of repeating the data, we go with reusability. So what we can do, that instead of repeating the data, we can go towards the inheritance, that we can create a single class, and we can create common data members over there, common data function there, and after that we inherit the classes from that. And the derived classes will have all the data members from the parent class, and they will also have some of their own data members. So in that way we can get, or we can meet the rules regulation of object-oriented programming, that we are reusing the data instead of repeating the data. Here you can see that we are repeating the data, we are not reusing the data. But in that case you can see that we are reusing the data, we are not repeating the data. We have a multiple inheritance. For example, this is single inheritance where the data members of A is inherited by B only, and there you can see the multiple inheritance where the class B is inherited by multiple classes. So all the data members of A, all the data members of B will be available in the C. In the same way, there was a multi-level inheritance, and we observed the same, that all the data members flows in the same way from B to C. And when we try to access the data members, public and protected data members of A from C, then you observe that we successfully set and get the values. The third one is a hierarchical, where from the same class multiple classes are inherited, and this is the popular way of inheritance. We use that in our programming languages, and you observe that it also works perfectly. The fourth one is a hybrid, and in the hybrid we derive two classes from a common class, A, and from that common class we write one function over here, and the same function copy was created by B, the same function created copy was created by C. And when we derived the function d from b and c, there was a confusion with the compiler that according to the object-oriented programming, we can't repeat the data. We can't reuse the data, but here the data is being repeated. The b has the same function, the c has the same function, so d was confused at that time. That such like issues are called a diamond problem, and for that diamond problem, to solve that diamond problem, we virtually derive the b and we virtually derive the c. So I think this is enough for today, and you can exactly know how the inheritance work. I'm forgetting, we also discussed the a constructor behavior. There first the parent constructor will run, and after that the derived constructor will run. We also discussed the basic reason behind that, then why we do like that. And similarly in the destructor we observe that first the child class destructor is run, and after that the parent class destructor is run. We also discuss what are the main reason behind that. So hopefully you understand everything. Let's meet you in the next video. Thank you so much.